This shape, again, looks like the possibility of two rectangles, and we can divide them in several different ways, but the way that they're showing in first here is to divide it here, where that little dashed line is. And here they showed what would happen if you put the dashed line there. Either will get you the correct answer. Doesn't matter where you cut the figure up, as long as you get the measurements accurately, you should get the same answer. And that's what they're showing here. We cut the shape up into the two pieces here, and then we calculated one as 4 by 7, and the other is 2 by 3. And that came up with 2 by 3 is our 6, and 4 times 7 is 28, and the area is 34. Again, area is length times width. That's how we did this. And we always label area square. That's why it's here labeled with like cm and a little 2 up there. That stands for square centimeters or centimeters squared. And that implies that we're doing area because instead of going around the outside of this figure, we're actually covering it up with little bitty units called square centimeters, just like tiles on a floor or a ceiling tiles. Now, the second way to divide it up would have been to cut it this way. And again, now we have 4 by 4 and 3 by 6. That gave us 16 and 18, but that also came to 34. So even though we cut it in a different way, it does not change the area. The size of the area does not change by where we cut it up. That's why the square footage, or the square centimeters in this case, would not change. Now in example 4, rather than comparing the perimeter, we're going to compare the area of the two figures and find out which figure has the greatest area. Figure A is a rectangle with a semicircle, just like before, only area is different. So we're going to do length times width for the rectangle. That's where our 10 times 4 is going to be our 40 centimeters. And then we're going to have to find the area of a semicircle. So we use the area of a circle, pi r squared, okay, and then we cut that in half because we're finding the area of a semicircle. Now, since the area of the circle is about 12.56, the area of the half circle is about 12.56 divided by 2, or 6.28. And the total area then would be our 40 plus our 6.28 for 46.28. And again, we label this centimeters squared because we're finding area. We divide figure B into two pieces. We pick a rectangle and a triangle because those are things we know the shape of and we know how to find the area. So we're doing 4 times 10 is 40, and we're going to do base times height divided by 2 because that's the area of a triangle, or 1/2 base times height. Means the same thing. So we're going to do 3 times 4 because we remember that when we figure the height of a triangle, we never use the slant height, the 5, that's the hypotenuse. We have to actually take the height off the right angle, so it's 3 times 4 is 12, and half of 12 is 6. So we either call it base times height divided by 2 or 1/2 base times height. They mean the same thing. So we get 40 plus 6 is 46, and we find that the figure A in this case has a greater area. Figure A has a greater area than figure B. We can always use what we know about angles to find the angle measures in complex shapes. So we're moving on to angle measures. We're going to find the angle measures of angle A and B in this figure. And what we're going to be looking at are our givens. We can see that there's a 130-degree angle over here to the side that's labeled. We're going to see that this is a 90-degree angle because this is labeled 90 and this one is supplementary. It fills it in, it supplements it. The again, then this has to be also a 90-degree angle. So we're going to look at some facts that we know, some givens. This is a straight angle, or a 180. Since we're given 130 plus A has to equal 180, then we know that A must be 50 degrees. So we know that A is 50 degrees. And then we go in and we figure that if in this triangle, and I'm going to make it a little bigger over here, a little hard to see otherwise, that this was a 90, A is a 50. We know that triangles are a 180, so we know that 50 plus 90 does not make 180, that makes 130. So 180 has to equal 130 plus B. And that was the B that goes up here. So, I'm sorry, I said 130, it was 140. So B has to make up the difference of 40, so B must be 40 degrees.